Okay, let's try a radioactive decay problem. So we're going to find the half-life of strontium-90, and we're given that 2.5 nanograms decays away to 2.05 nanograms in 8.4 years. So it's going to be some decay process, exponential decay like this, and all we have to know is, we had 2.5 nanograms here and 2.05 nanograms here, and how many years elapsed was 8.4 years. If we know the time between these 2 points, we can find the decay rate, or we're going to call it the half-life. So here's our equation. This is off of worksheet log applications worksheet number 3. C equals C0 times 2, and that's a fraction exponent, t, divided by the half-life. So t raised to the exponent, 2 raised to the exponent, t divided by h. T is time, h is half-life. And that'll be in the same units as time. So if t is in years, half-life has to be in years. If t is in seconds, half-life will be in seconds. But they're both times using the same units. Okay, so what we know is 2.5 nanograms decays away to 2.05 nanograms. So it starts at 2.5, that's the C sub 0, and then it ends at 2.05, which is the C. So it's getting smaller, there's getting to be less of this stuff, it's decaying. And we know that it took 8.4 years to do that, so that's going to be the T. So the equation looks like this, 2.05 equals 2.5 times 2 raised to the 8.4 divided by h years, okay? So this is an exponent, 8.4 divided by h. Now, this is an exponential equation because the variable is in the exponent. So to solve exponential equations for that exponent, we're going to use logarithms. To use logarithms, we have to have the base and the exponent by itself. So I need to get rid of this 2.5. It's multiplied. The way I get rid of things multiplied is I divide by them. So I divide both sides by 2.5. And again, we're only going to work on the left side here. So it's going to be 2.05 divided by 2.5, and that's 0.82. So this thing is 0.82. Leave a space over here. So it's going to be, I'm going to put the 2a over here, and it's raised to the 8.4 divided by h power. Okay, so that's the power right there. Now, if I have the base and the exponent by itself, I can take the log of both sides. I'll use ln this time just to be different. So ln on both sides, and when I do that, grab that exponent and put it down in front. So the whole exponent comes down just like it is, don't change anything, and it goes down in front and multiplies times ln2. On the left side, I'm going to take the ln of 0.82. So let me find out what that is. ln of 0.82 is negative 0.198, negative 0.198. And over here I have 8.4 divided by h times ln of 2. So I've got a fraction down there in front of ln2 multiplying. The problem here is, what makes this a little bit tricky is I'm solving for h, which is in the denominator. So h is in the denominator. I've got to get it out of the denominator into the numerator, solve for it. So the easiest way to do that is to multiply both sides by h. When you multiply here in the numerator by h, it cancels out that h in the denominator, and I multiply over here by h also. So what I have now is I've got h times negative 1.98 equals 8.4 times ln2. And now what I want to do is I want to get h by itself over here on this side. So I'm going to divide, this is multiplied, the negative 0.198. So I divide by negative 0.198 on both sides. So this is gone. What's left on this side is just the half-life. What's left over here on this side is 8.4 times ln2 divided by 0.198. And what I'm going to use, I'm not, don't ever hit clear on your calculator. I'm going to call that the answer, so I won't have to round at all when I do this on my calculator. And now notice here we are doing a calculator operation on the right side of this equation. So this is, a little bit unusual when you're solving for denominator. You end up doing that, using your calculator on the right side of the equation here. So I've got that negative 0.198 still in my calculator. I'm going to go 8.4 times ln of 2. You've got to write all this down in notes so you don't forget what to do. You've got to be very consistent and meticulous about doing it down the page and writing down your steps so you don't forget something or get lost in here. It's pretty complicated. If you skip a step or try to take a shortcut, you'll probably get lost. So I have 8.4 times ln 2, and now I'm going to go divide by answer, so I won't have any rounding errors. And I'm going to put that number in memory because I may need it later. And that turns out to be negative 29.3. And because the original units was years, the half-life is going to be the same units, which is going to be in years also. Okay? And notice it turned out to be negative because I forgot to put a negative in up here. When I was originally setting up the problem, I probably should have put a negative in there. But if you forget to do it, it comes out and says, oh, it's decaying, therefore it has to be negative. So your answer, the half-life, there has to be a negative in that problem someplace. You can put in there to start with, or you can, wait in the equation will tell you it's got to be negative. It's decaying away, so you have to have a negative in your exponent. All right, so very hard problem. Practice that. And if you want to check it, you could check it by putting it back into here and seeing that, that you actually end up with 2.05. So let's do that. Let me show you how you do that. So I'm going to go 2.5 times 2 to the 8.4 divided by negative 29.3. And I'm going to use answer, so I'm not going to round. And let's see what that equals. So right here, I'm going to go 8.5 divided by answer, and that's negative 0.2897. Now I'm going to go 2 raised to the answer power. So I'm going 2 raised to that negative 0.2897. You don't have to write these steps down. I'm just writing them down so you can follow them. So I did 2 raised that answer equals 0.8181. And then I'm going to multiply that times 2.5. And when I do that, I get 2.045, which is pretty close to what I started with. Okay, so that's a good check. All right, practice that.